This is my nuclear project. I'll explain all the nuclear processes. Fusion. Here there is fusionable nuclei. What makes this fusionable is because they are very small and have a lot of energy. Here shows the nuclei joining at fast speeds. The strong force overpowers the EMF and the strong force glues the nuclei together. Here the nuclei have joined and now there is a release of energy. This is because there is one stable nucleus, so it needs less energy and the leftover energy is released. The final product of fusion is the two nuclei glued together. Fission. Here a neutron is going into the nucleus of the original atom. The strong force then becomes disrupted in the nucleus of the atom and there is a battle between the EMF and the strong force. Both the forces win and then EMF splits the nucleus, but the strong force still holds the smaller atom together. These atoms can either be stable or unstable. And then 3 new neutrons are released. Also energy is released because less is needed. Because there is less for the energy to be inside of, there is nowhere for the energy to go, so it has to be released. Nuclear decay. Nuclear decay is the process in which an unstable atomic nucleus loses energy by emitting particles and radiation. Alpha decay is when 2 protons and 2 neutrons leave the nucleus of the radioactive isotope. An atom would need to undergo this decay so the mass will decrease. Beta decay is when the neutron turns into a proton. The beta particle then leaves and the new proton stays at the nucleus. Positron emission is when protons decay into neutrons and a positron. The positron leaves and the neutron stays. An atom undergoes this decay, so protons decrease and neutrons increase. Half-life is the amount of time it takes for half of the radioactive particles to decay. You start with all the atoms being radioactive. Over one half-life, half the atoms become stable. However, you cannot change the pace of decay and type of radiation, and more radiation is released in the beginning than towards the end. Radiation decreases by 50% after each half-life.